Welcome everybody. In today's lesson, what we're going to do is we're going to open up the Pix4DCapture app, and we're going to explore Pix4DCapture and what it has to offer, some of the general settings, and which is down here, some of the general settings, how to set up a mission, and go from there. So I have my iPad here, and what you're going to want to do is go, if you have an iOS or whatever type of mobile device. This could be a phone or an iPad or tablet. Go to the App Store on your device, search for Pix4DCapture, and it's this little green logo right here, okay, that I have kind of wiggling around on my screen. Download that. Once you download that, you can go ahead and, again, this is totally free. I mentioned this in the field. There's no charge for downloading this or using this as much as you want. That's why we like to use it for teaching, etc. So we're going to go ahead and open this now. Okay, Pix4DCapture here. What you're probably seeing the first time you open this is something about an account. So follow through with that process as they are asking you to do so. The same account will be used for you if you have a private license of the software or a trial license of the software. But go ahead and do that and follow through, and then come back to this video if you need to. After you've gone through and created the account process and confirmed, again, the account is free. This is nothing that you're paying for. I just want to be upfront about that. You're going to pay for your account, or you're going to establish your account. Not pay for it. You're going to establish your account, and then you will be able to access this app. So once you've done that, you'll see the app's home screen look something like this. And before we go into the mission settings, I want everybody to come over here to settings. These are the general settings of the app. And the first thing I want you to do is, you might see something like this. So on the left side, what we're going to be doing is establishing which drone we have, and this is going to help us plan our mission. Do this in the beginning, because if you don't, what you're planning won't sync exactly with what potentially your project will actually look like when you hook up your drone. So say, for example, I have Mavic Air selected here, and if I then hooked up a P4P, the mission is going to be totally different in terms of its specs and whatnot once we actually have the P4 hooked up. So it's important to do this now, and you could select either DJI or Parrot. Those are the two brands that are available. Parrot has a nice little collection of smaller drones. We're going to work with something from DJI. Whatever is selected here, I want you guys to go in and choose the Phantom 4 Pro. Just the Phantom 4 Pro, not the V2, just the Phantom 4 Pro. That's what we use at the DVC class. And yeah, so other thing to note here, I'm going to explain some of these little settings. You have your camera here. If you had a drone like, for example, an Inspire or one of the Matrice that had an adjustable payload, you would see those show up here where you could choose the various cameras. In this case, the Phantom 4 Pro only has one type of camera, so it chooses the Phantom 4 camera. You could also input a custom camera if you have that information available to you. I have put something called a P1, but if you have something else, you could enter that here, which we're not going to do. But just showing you some of these settings. Under map, this is going to be establishing what type of base map you're using. Mapbox works perfectly fine to me. And offline map, that works well too, because what you're going to do is it's going to save the cache if you're establishing this in an office where you have Wi-Fi. And then you don't necessarily need Wi-Fi when you go out into the field. Your units, straightforward. You're either going to be working with metric or imperial units. So I'll just leave it to meters just for this exercise. That's fine. This little setting here, auto download images when mission ends, I'm going to turn this off. And the reason why, what this does is we fly a mission, and then the app will try to automatically sync all of your images to what's called Pix4D Cloud. And I know that this is something that we haven't even explored yet, but the reason I don't like this is because instantly it's going to start eating up your cellular data. And unless you have that kind of bandwidth, number one, it takes a lot of time. But number two, if you're on some kind of plan where that bandwidth is limited, you could be chewing it up unintentionally. And for what I like to teach in these courses is taking the hard copy memory stick out of the drone anyways and processing it locally. So I'm not even going to use this capture in this instance. So I turn this off and that thing is not going to happen again. Upload resolution is related to the capture, so we don't have to, or related to the cloud upload, so we don't have to really change that at all. And then, obviously, if you're flying in China, this would be something you check or don't check, which we are not going to do here. Let's go back. We're going to go ahead and close this now. I've got my mission types available, so I'll walk through and briefly explain these. Your polygon, and before I do, let me just say a couple things here. They have these little explanations down on the bottom. 4 2D maps, 3D models, single 3D model. Really, this is the only one that kind of makes sense for this circular mission, single 3D model. These other ones, 2D maps and 3D models, I think that the language here is a little misleading, and let me tell you why. With a polygon mission, you're performing photogrammetry when you upload the images into the software. And through this process, as you guys will experience, you're going to be able to produce 2D ortho and 3D point clouds and other types of products or deliverables. So this and this are more than capable of producing 3D as well. I just want to, make that clear to you guys. Sorry about that. Don't be misled thinking that you have to fly this thing called the double grid in order to get any type of 3D out of what your purpose and mission is supposed to be. Now, this double grid provides a denser 3D version of what you're flying. And I have more information on this in theory, and I will provide that in a slide deck at a different different time in the course. So for now, we'll just kind of put a hold on this one. The circular, similar type of thing, the reason why I said this is actually kind of accurate language is because what we're talking about is flying a point of interest around an object. And what ends up happening is the images overlap obliquely, and that, again, produces, when we run it through photogrammetry, we end up producing something in 3D, very dense, potentially, very dense. But you're talking about type of singular structures or, a collection of something kind of focused and not like a landscape per se. This free flight is interesting. Free flight is a function where you will fly essentially like you are emulating a mission type. And how it works is you fly manually trying to fly straight lines and whatnot. And what this app does is, what this mission does is it allows you to set various spacing or other conditions for when the app will take pictures for you. So in one way, you're doing it manually, but in the other way, the image capture itself is taken care of with the app itself, based on where you are flying. Kind of a training thing, not necessarily something that we're going to use too much here, but that's okay. Let's go into this one here, polygon, because this one is going to give us the most flexibility where we can adjust the shape of our mission to whatever irregular shape that we want. So I'm going to do that here. And what you'll see is a base map, and you'll probably see it. Let me do this. So you'll see it where your home screen, where your location is of your device. And you have a little blue dot, which is going to be that location here. You're going to use the base map as a guide for establishing the location of where your mission is going to be, where you're going to fly over. So I want you to do that now. That'll be the first step of this little exercise. We're going to create a polygon mission And honestly, guys, frankly, here in this circumstance, I think honestly, what I'm expecting from you, you can create a mission anywhere in the world, okay? Anywhere in the world that you think is interesting, that would produce something of, hey, I would love to see a 2D ortho of that, or a 3D model, whatever. Some type of landscape. It could be a famous place, I don't know, Disneyland, or the Taj Mahal or something, whatever. Or it could be something as simple as, hey, I just want to see what my neighborhood look like. I don't care. What I'm looking for is uniqueness amongst all of you. So find something like that, okay? I'm not going to necessarily go out on a limb here. What I'm going to do, with all of that being said, is I'm going to go over to DVC's campus in Pleasant Hill. So I know you can't see where my finger is, but I'm just using my two fingers to kind of zoom out like any kind of map operation. And I'm scrolling. Actually, here, I can do that now. I'm scrolling with one single finger over to the location I want. Now, I know this is a little tricky. You might have to open up Google Map to see the labels as well. But once you figure that out, what you're going to do is you're going to zoom in to your location. Okay, so like, for example, here's DVC's campus in this kind of square shape like this. And so the objective is to establish our mission over this particular location, over this landscape. I've already got something built here. You probably don't. But what I'm going to do is I'm going to reset this to just be a standard kind of square. And I could do that by using this little button here. Reset the shape and location. Yes. And as soon as I do that, this little small version of my mission is going to show up with just a square kind of shape to it. Now I'm zooming my map out so that I have the full extent of the campus in this example. And what I'm going to use is my fingers over these larger green nodes, I'll call them, and I'm going to click and drag them around. So the intention is to fill up the entire space, even with a little bit of overshoot of where I'm intending to map. Now, you could do kind of the big four first, right? And then, for example, I've got this other street. This is Viking Drive. I've got this street here that's not quite covered up, so I want to add a vertice here. And the way that I do that is I use my mouse and I click on one of these little nodes with the plus, and then I just click it and drag it over to where I want it to be. So maybe I want to drag this one out just a little bit more, and maybe I want to drag this side out just a little bit more. Whatever odd shape you've got in mind for your site, go ahead and establish that now. Other things you could do, you can nudge the map without adjusting the actual shape of it by clicking in the middle here and just holding it and moving it around, so that moves the whole thing. You can also shift the direction of the flight lines. This is helpful because the tip is longer flight lines, like if you have something that's more of a corridor shape or rectangular, longer lines are going to equate to extended battery life. So what I'm saying is the less turns that you have, like these at the top and on the bottom, the less turns you have in your mission, the more you're going to get out of the battery itself. So you can fly longer in that instance. And this is, I guess you could say, kind of more this way. So that's what I'm going to do here, kind of angle it this way. I know that the start and end points are a little bit off, so you might want to adjust like that. Okay, so an ideal mission would have the ending point at the end of a solid line. And I know that that's not always going to work out, but you don't really want to have long dotted lines for your end. Okay, now here I am. I feel confident that I've got the coverage of this mission. Let me explain a couple more things before we, as we go through this. On your right side here, this little panel, this is going to show you dynamically what's going on when the mission is occurring. So, for example, it does say here Phantom 4 Pro and Phantom 4 Pro camera. That's what we're planning for. All of these are 0 because I don't actually have the drone hooked up. But once I do, these things like the battery life of the drone, the telemetry strength, and the satellites, all of these are going to show up for me, giving me information to view as the pilot in charge. My speed, vertical speed, and my altitude, these are going to be also extremely important as I am monitoring the operation in real time. Let's move over to the left panel here. And I've got my height. And remember, at the beginning in my settings, I had everything set to meters. So this is an M. If you have yours set to feet, this is going to be FT. And you'll notice that the wheel that you scroll along is either going to be really long or it's going to be kind of shorter as we're working with meters. This will allow you, as you scroll this up and down, I guess I can't, the feature I'm using doesn't do that, but I'm going to use my finger to scroll this back and forth. This will allow you to essentially go to an unlimited altitude. So I have this set to 202 meters, which, by the way, if you think about it and you did the calculation, I am now over the legal limit for a ceiling of flying a drone in Class G airspace, because 200 meters equates to something around 500, 600 feet. I'm over the 400-foot limit. So part of this exercise, I want to see you guys keep your flight altitude at or below the 400-foot ceiling, okay? So I'm going to be paying attention to that as I look at your screenshots that I'm going to tell you about. So in this case, I'll just give you an example. Meters to feet, 120 meters is pretty darn close to 400 feet. So that's where I'm going to set my altitude in this case. Other notes to pay attention to, look at my GSD, okay? This is our spatial resolution, our overall picture detail that's going to derive from this product. And as we know now from the theory, the lower we fly, the lower this number is going to get, which means, in turn, the higher the resolution is going to be, i.e. the more detail we pick up. Like, for example, I have this set to 120, and I'm picking up 3 centimeters, 3¼ centimeters per pixel. If I move this to, let's try half of that, which would be 60. Whoops, 60. Okay, obviously my ground sample distance has changed, but look at my map. What happened there? Notice how many more flight lines were added to the process, because I'm flying much lower and my footprint is much smaller, meaning that it's going to take a lot more flying to get the same amount of coverage, okay? So other ways of kind of helping you determine how you're going to fly at what altitude, etc. Pay attention to down here. This so much is not extremely helpful because it's kind of giving you a general square meter of your site. But down here, this estimate of time it's going to take to fly, this is pretty darn accurate. I would say within about 10 to 20 seconds worth. And right now I have this set to 91 minutes. And the thing is, a Phantom 4 Pro, at least on one battery, is not going to be able to accomplish this feat last 91 minutes. So keep that in mind. And I'm not saying you have to do this battery by battery, because I explained the nice thing about this app is that if you have multiple batteries on hand, you could set up a mission like this, fly a portion of it. The app is smart enough then to stop the drone in mid-flight when the battery is low, come back to you, allow you to swap the battery out, restart, and then actually resume the mission at the last point. So you could have a mission like this that might take you 5 to 6 batteries, something like that, okay? And that's totally possible. That's totally possible. And by the way, in this example, for your objective, I frankly don't care how long it takes you to get the mission accomplished, as long as you keep to the no higher than, if you're working in meters, 120 meters, and if you're working in feet, no higher than 400 feet. Notice the difference in that. Now I'm down to 28 minutes. So this is about a 2-battery job to map all of DVC's campus. Okay. Other things on this screen that I want you to pay attention to: when we are in the field, you have this ability to turn your camera's view on and off. So this is a nice little just to have thing. If you hit that little thing, it will expand the whole screen for you. It doesn't do anything other than it's something to visualize. Over here in this setting, on the far right side, top side, you're going to see normal as being the first thing you see there. I'm going to show you the advanced. So go over to advanced. Now they've got angle of camera, 90 degrees. They're considering the camera pointed at a nadir position to be 90 degrees. Okay. There are times when we will not set this to 90 degrees, where we will set it to something other than that. But that is not the time for this discussion. We will get into that further when we talk about advanced mission planning. For now, under a polygon type mission for standard photogrammetry, we're going to keep this at 90 degrees. Your front overlap and side overlaps are next. Now, I don't know what your defaults are set to. The nice thing about this is when you set it once, it stays in the app until you change it. What I want you guys to do for your own experience here is to change these values around and then log back in. So like, for example, if I set this to 90, or actually here, let's do this because you'll see the visual. If I set the side to 90 and then I go back here, check out how many more flight lines are established. Okay, so I want you guys to just toggle those settings back and forth a bit and see what happens. And then eventually, I want you to come back and I want you to set this to our standard recommendation, which is 75 in the front, 70 on the side. And once you've done that, you'll consider that to be a finished, I can move on from there. Look at grid center, no or yes. In the no setting, what happens is the drone will, instead of the heading always following the forward position of the mission, and then making kind of these 180 degree turns as it goes back on each flight line. The grid center means that the drone will continually rotate on an axis and continue to try to point to the center of the mission. Frankly, I haven't really found out, other than some advanced 3D modeling, what this could be useful for, and certainly won't be applicable in this setting. So for this, we're going to definitely keep that at a no. Trigger mode. Now, fast versus safe. I want to be clear about this because it's another kind of misleading terminology. Fast mode means that the drone is just going to continually fly and take pictures sequentially. Boom, 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 in its forward overlap mode. The reason that they have something called safe mode is designed to keep your pictures in the event of, say, the drone stalled for whatever reason, or the memory card stalled. And even though the drone is moving forward at 20 miles an hour, maybe it missed 2, 3, 4, 5, 20 pictures in sequence, okay, for whatever kind of malfunction. Safe mode will prevent that. And the way it will prevent it is it will fly to each, as it's flying its straight lines, it will stop the drone every time it's supposed to take a picture. Take a picture and then move forward. So you can imagine in safe mode how much longer it actually is going to take to complete a mission type. For me personally, I have only flown safe mode under testing and have never flown it again, just to be clear, okay? Drone speed is another, kind of oddball thing. The thing with drone speed, to be frank, your drone speed is going to be determined by your front overlap. The higher your front overlap, actually two things, front overlap and altitude, because we're talking about footprint. So the lower altitude and the higher your front overlap is, the slower the drone has to fly in order to ensure it captures that amount of overlap. So I always just leave this in the middle because I haven't really found either one of these being something that actually makes a difference. I just leave it in the middle, okay? Your white balance is something that will that will matter. Do not set this to auto. I promise you, because what happens is with white balance, the camera will try to overcompensate. Like if you have something very bright on a sunny day, any kind of white objects in your scene, or any type of reflections in your scene, and you'll end up with too much variation in the color saturation of your pictures. So by setting either sunny or cloudy, depending on the scene conditions, okay, take a look around you. What's going on around you, okay, in the sky? You're going to want to set these, because then you won't have this overcompensation in your picture's exposures. White balance is great, as you learn in 164, in terms of adjusting kind of artistic photography. But when it comes to photogrammetry, you want something that is fixed for the actual environment. And then ignore home point in takeoff checklist. Ignore home point. Yeah, we're going to leave this as no. Essentially, if you put this to yes, what it's going to do is, say you moved the your position as you were taking off. When you say yes, then the drone is actually going to reposition where its home point is. And frankly, that could be, just a little bit too much going on or trying to manage at one time. For my recommendation is to keep your home point in the same place when you take off and when you land, and don't disturb it, okay? Don't disturb it. Now we'll go back. That's the settings. All right? When you've got your mission done and your settings set, you could save your mission down here by clicking this little save button, and it'll generically call it project whatever number, okay? You'll notice that it's caching the map down here. So you can come back to this later on, and then you could load this up into the field. Say you have to charge the iPad or whatever it is. When you actually have it ready to go and you're starting the mission, you click the start button. And I can't move forward here because I have to actually connect the drone. But once I do, I'll click next. Another window will show up, which is a pre-flight checklist of the drone's mechanical and electrical components, making sure those are working and functioning okay. As long as I have all green check marks working out and I'm ready to go, I click the start button, the drone will turn on, or the motors will turn on, and within a few seconds the takeoff will commence. Takeoff commences, we will see the drone here, it will also show up as another icon, and it will fly to the starting position and begin the actual mission. The great thing is the entire operation is fully autonomous unless something happens where you need to take over. And in that event, this button down here during the actual mission will turn into a pause or return to home option. So that is Capture explained to you. The objective that I would like to see here is that you provide me a screenshot of this. So like, for example, I want to see where the mission is. I want to see that you've got your, and again, don't do DVC, okay? Pick something else that's unique. But I'm looking for that you've set the Phantom 4 Pro here, that your altitude is something, legal. Yeah, then you're good to go. So that's the goal. Upload the screenshot to Canvas, and we are all set. Okay, thanks everybody.